Rigid body constraints are used to hold two rigid bodies together. You can add a constraint by adding an empty. So let's just press Shift A, empty, and I'll use arrows so that we can see the axes, which will come in handy later. And then in the Physics tab, just enable rigid body constraint. So at first it won't do anything because it needs to know which two objects it's connecting. So under Object 1, I can either select from the dropdown or use this little handy eyedropper tool to select the rightmost cube, and in Object 2, I'll select the one in the middle. Now when we play back our animation, those two will be fixed together. Now there's an even easier way to add constraints to objects. Just select two active rigid body objects, or you can select passive ones as well, and then in the toolbar under Physics, click Connect. And that will just do all of the work for you. So if we select one of these constraints, we can see the settings for it and change some of the options. First option underneath the objects is breakable, and this will allow the object to break if it's under a certain amount of pressure. The threshold is how much pressure is needed in order to break it. So we could either set this threshold really low, and that will break the constraint. So we could also increase the mass of the object that's falling, and that would increase the force as well, and put more pressure and break the constraint. The override iterations option allows you to set how many times the constraint is updated per step. So if you leave this unchecked, it'll just use whatever you have set in the rigid body world settings under solver iterations. But that just allows you to set it per constraint in case you need a custom solution. So now let's take a look at the different types of constraints. The first one that we've already looked at is fixed, and that just glues the objects together. The next one, point, allows the two objects to rotate around a point in space, and that point is exactly at the origin of our empty. So if we play that back, you can see that they're now rotating around that point. However, they're not colliding with each other, because to save memory, Blender by default disables the collisions when you have constraints involved. But to disable that, we can just uncheck the disable collisions option, and now when we play this back, then they'll run into each other just like we would expect. But I'll leave that on for now because it makes it a little bit more clear what's going on when we're explaining some of these other constraints. Next up is hinge, and this allows rotation around the z-axis of the constraint object. So it works just like a door hinge. There's also a new option for limits, so if you enable this, it'll only allow it to go within those bounds. So if we set this to 0 and maybe 10, it'll only allow it to rotate within those degrees. The next constraint is a slider, and that allows the object to move along the constraint's x-axis. So if you play that back, you can see that it's slipping a little bit on that axis. It looks like you can't see it too much, so let's take the constraint and rotate it 90 degrees on the y-axis. So you can see that the x-axis is now pointing up and down, and that's the local x-axis, remember. So now when you play this back, it'll allow it to slide up and down, but it'll keep the rotations constrained. So you can also set limits for that if you'd like. And any of these other following ones have limits, so I won't be going over that for each of them, but I'll just point out where they are. So next up is a piston, which is very similar to a slider, but it also introduces angle constraints. So it'll allow it to rotate along the local x-axis as well as slide. The generic constraint lets you set your own custom limits for any axis, so that can be really handy if you have a really specific effect that you're trying to get. If you enable one of these and just set it to 0, that's basically like locking that axis. Now the generic spring, like the name implies, adds springs to the generic constraint. So let's turn off all of the limits, but let's turn on some of these springs. So if we turn it on for X, Y, and Z, they're going to try to snap back together as if a spring was connecting them. Now the stronger you set this, the more stiff those springs are going to appear, and the quicker it'll settle back to its original location. And lastly, we have a motor constraint, and by default it won't do anything because you have to either use a linear motor or an angular motor. So let's first take a look at the linear motor. What this does is push objects away from each other on the x-axis. So right now our x-axis is pointing down, so let's rotate it 90 degrees on the y-axis. And if we play that back, so you can see now the objects are pushing each other away on that x-axis. And if you give this a negative value, then it's going to have the opposite result. Now if you disable linear motor, you can also enable angular motor. You could have them both on at the same time, but it makes it a little bit more confusing to actually see what the difference is. So a positive value will have them rotate towards each other on that axis, and a negative value will have these objects rotate away from each other on that axis. And of course, by rotating the constraint itself, let's rotate it another 90 degrees on the Y, then it'll change which axis it's being rotated around. So that's a quick overview of all the constraints. It's a little bit hard to visualize them with just these quick examples, so I'd really recommend going through them for yourself if you're interested and playing with them and getting some hands-on experience, and you'll pick them up in no time.